Hello everybody and welcome back to Micronova Metals. Today I'm going to walk you through making your own nitric acid using two ingredients. You're going to use some sulfuric acid and potassium nitrate, and essentially we're going to put the dry mixture of the potassium nitrate down here. We're going to do 1,000 grams, and then on top of that we're going to pour 1,000 milliliters of concentrated sulfuric acid, and turn the heat on and drop a stir bar down into here, and essentially it's going to start reacting and converting, gaining its own heat, and we'll distill down this tube here into this vacuum flask attachment, and this is going to allow it to vent. Normally I would put a temperature or thermometer up there, but last time it actually fell down into the bottle and no longer holds this. It'll just slip on down through, and I don't need it breaking inside during the reaction. So there's going to be relatively little going on, but it is very time consuming. And out of the 2,000 grams or 2,000 milliliters of ingredients that I'm going to use, I hope to get 650 to 750 milliliters of nitric acid out of that. And that should be very high concentrate under this setup, somewhere around 90% to 95%. If I don't get it, it's probably because, as of yet, I do not have a water-cooled tube here. And I might lose some potency because of that. But regardless, it will be a very good acid I can use in multiple applications, and a lot cheaper at that. From what you would buy it for commercially. So without further explanation, I'll have a couple more words to say here and there, but other than that, it's going to just be a play-by-play. So on a quick side note, one thing I forgot to point out is because this doesn't have a thermometer going through it and I don't have a solid cap, if I left this as it is, a lot of the dioxide carrying nitric would go out with it and right up the fume hood here. So I've got to plug that with tissue paper. It's not ideal, but it's just what I have today, and it works. I've already done it. So okay, so here I've already weighed on the scale 1,000 milligrams of potassium nitrate. Now this is purified, crystallized potassium nitrate that I got from Duda Diesel years ago. I got a 50-pound bag of it. What I will say is that I did go a little bit heavy. I think I went up to 1,050 because there is inherently some water in this. It is hydroscopic, which means it wants to get water out of the atmosphere and pull it into itself. So I recommend you put the dry ingredients in first, and I say that because if you need to clear your funnel, you don't want to do it when you already have stuff reacting in the beaker. I just try to feather it in, and if it does clog up, it's no big deal. You can use one of your glass stirring sticks to unclog it. So I'm going to finish up the rest of this off camera, and then we'll move on to the next stage. Okay, so the next ingredient is concentrated sulfuric acid. See if you can see, I picked this up from a local hardware store, somewhere between 93-95% concentrated, I do believe. I don't know exactly. I'm going to need 1,000, but I am going to instead do 500 at a time. And one thing I do want to point out is that this is the same measuring cup that the potassium nitrate was in. So I did not wash it down. What I did was I just dry wiped it with a towel, and that won't hurt the towel or anything. And I did that because I don't want it reacting with potassium nitrate in there. So what we have prepped is right here, glass funnel. You'll see that there is some dry potassium nitrate on there. That's okay. It's going to go down in there. And you will see that once it goes in there, it will start reacting immediately, but it's not a very quick not a very volatile reaction. It's kind of like a rolling thunder. It will just create its own heat, get hotter and hotter, and eventually become molten in there and start producing nitric acid. So the part that you're not going to see, because with my current setup, I'm a little constricted with how I set up my space. I mean, this is my vent hood. It's at least 3 feet wide, 3 feet deep, at least that size. But having said this, I've made a little plexiglass containment area so that all those hot reactions and dioxide producing reactions are going to be, contained in there. So after I pour the sulfuric acid into here, all 1,000 milliliters of it, I have to put sulfuric acid on the joints here with a pipette, anywhere that there's a connection, so there won't be any nitric acid leaks. A little might get out, but it's no big deal. It's all going to be in the vent hood. I'm going to use this and one of my pipettes up there to do that. So you're going to miss me actually doing most of it, but it is an important step. Okay, let's get the vent hood going. All right, and in we go with the first 500. Just slow and steady. Slow is smooth, smooth is fast, and safe in most cases. Start to be a little purpley down there. That's just a very cold reaction. It is an exothermic reaction and it will pick up speed. So I'm going to just place that back there a little bit and put in the next 500 into here. And I'll do this part on camera so you can see. You don't have to. Okay, there's my little super scientific TP plug in lieu of a glass thermometer and mini gasket. And if you need to know where to get that, it's in any hardware store next to elbow grease and blinker fluid and all that kind of stuff like that. But rapidly moving on, I have the magnetic stirring stick. I'm just going to drop it down the tube. There it goes. Give it a wiggle, not a shake, give it a wiggle. I didn't want to put that down there immediately. I changed my mind on that because I don't need the plastic just baking. And now what I need to do is put my gloves back on and seal this joint here. And everything's going to sit there for hours. All right, as I'm sealing this up, let's talk about these little apothecary bottles. I got all of these on eBay. I have them for concentrated sulfuric. I have them for concentrated nitric. I have them for concentrated hydrochloric acid. And I have them for dilute hydrochloric acid. And they are expensive. I don't think I paid anything less than $30 for one of them on a deal because the lid didn't fit. I don't know if I paid any more than $60 for one of them just because I wanted it. And that's what it comes down to. And why do I want it that bad? It's because it provides what I call a little bit of an emergency brake. So you can see that's your last visual that the right thing is going in when you're dosing things into your solutions to get let out or more nitric or whatever it may be. So we're rolling. I'll show you something when I've got something to show you. 5 minutes into the reaction. You can see up in the distillation tube up here. I really should be wearing gloves. I almost walked away for a second to clean some equipment, but let's do this. Getting some yellow in there. That's just the fumes. So we're underway. Eventually, this potassium nitrate will float up to the top, and it'll get the stir bar going. Actually, we might even be there, but I'm going to give it a second. Stirring stick in motion. I'm not confident it's even hit the bottom yet, but I have no way of checking without moving this apparatus around in the way that I don't want to. But once it finds its way to the bottom, which it will soon, it'll get everything all mixed up. Very nice. Okay, so we are about 15 minutes into the reaction. I just saw the stirring stick drop, so we're going to get that in motion. You can see with the reaction taking place now, the mixture is starting to produce a lot more fumes, a lot more heat in there. I'll get a temperature reading here shortly, but let me get that started. And you're going to see all kinds of motion down there. And probably that blob of potassium nitrate is going to drop and start breaking up. But if I hold still enough, yeah, you can see all kinds of stuff going on. I don't think that you have to have a stirring stick to do this. I really don't, but you can see why it helps. Yeah, all kinds of motion there. Let's see if we can get a temperature reading. At the bottom of that blob of potassium nitrate, it's 178. I'm getting 215 right below it. So somewhere around 240, there'll be some azeotropic acid being produced, and we'll start seeing it come down the distillation tube. And when that happens, I'll let you know. And I think at this point, I'm going to go ahead and wrap this up with tin foil. Okay, normally I think that this would be done, but just for demonstration purposes, I'll try to catch it on camera. Oh, I have it done. I really just wanted to show you what happened in the reaction from beginning to end. I got this, take your aluminum foil, shiny, pointing in, just like you were barbecuing, and give it a wrap. I would, of course, recommend you do this before. I'm taking the risk, honestly, of doing this during production, just because I wanted you to see everything that was going on. Because as soon as I put this shroud on, it's kind of an uneventful thing, but it's going to help a lot. And I just tuck it in. That's going to help prevent a lot of the draft, but still give me a little bit of a window to kind of see what's going on right in there, although it's going to be hard to see. but this is going to make it get hotter in there much, much quicker. Okay, so let's open up and see what we got going on here. So fumes are accumulating in there all the way to the top, and let's see if we can catch. We just saw the, we've had some drops coming down, but you can see there at the bottom. There's my stick here. You'll see one or two collect and collide there, and it's working. It's doing its thing up there. You can see the fumes up inside, all the way up in here too. So I'm gonna try to catch it, dropping some drops here in a second. There we go. There we go. Starting to find its way down the tube. There we go. Watch it go. Yep. So we're getting our nitric acid. So should be at roughly 70% at this point, but it'll be climbing soon. Okay, back with another update. Big changes in just 5 minutes. You can see. Let's see if I can get it. Yeah, you can see all the fumage going on up there. Lots of condensation on the tube. And right here at the neck, let's see if I can get a good picture here. Just look at the drops. Going. So it'll be a continuous distillation here till it slows down quite a bit. And because I don't have the temperature or the thermometer that I can stick in there, I won't know when it hits exactly 318, but I can tell you that when the drops hit towards the end of distillation, hit and settle differently, then that's pretty much when it's over. But for now, the whole time I've been talking, we have condensation and beating and all kinds of stuff coming down the tube, so we are definitely in production now. Okay, we're about an hour into this reaction, and I'm just gonna use my little pointer stick here at the bottom. That's the rate of accumulation right now. It's really moving along. See right here. Yeah, everything's looking good, looking really good. Right up here at the neck, it's just like all kinds of action going on. So yeah, I may have overestimated how much I'm actually going to get out of this. 700. No, I think I'm about right. So around 750, something like that. But with all this time going, now an hour into it, I'm only a quarter inch of liquid on the bottom of that. So, but anyway, it's happening. It's happening faster and faster. Okay, back with another update. Where to start? Rapid dripping down into the flask. Up here at the elbow, it's just like raindrops on a window. And if you look up here, it's just really cleared up. It's not completely clear, but it is close. So that just means to me that the impurities, for the most part, have been processed, and we're just making very concentrated nitric acid, which is exactly what was expected. And up here, just the last of the nastiness is doing its thing, and it's hard to see, but out of this nozzle, there is that fuming that I was telling you about was going to have. It's going to happen one way or the other. So, but I mean, if you take a look at this is crazy. I mean, look how fast this is coming down. So, rolling thunder, rolling nitric acid. Okay, just doing a check-in here. Let's see how far we are. 6. Well, we're a solid 4 to 4.5 hours into the reaction, and as you can see, I have a steady drip here, but 400 milliliters is what I've received out of this so far. And I was looking at the droplets going into the water. They appeared to be no longer sinking to the bottom, but kind of bouncing to the top. But I just can't say that with confidence. So I decided to pour this off into here. Saw it was only 400, and so I think we have, quite a ways to go, another 200 milliliters anyway, and it's still going. I mean, so I can get, it looks like a continuous rain, and it's actually a neat effect if you look underneath. Just like that. So cool. It's like just droplets just racing to catch up with each other. So I guess we're in for a little bit of a long haul here, and we're not done, but it looks like everything just looks good. Everything's working the way it should. I meant to capture this too, so this is the boiling flask in here. I just parted the aluminum foil a little bit, and it's pretty vigorous. It's doing its work too. So this is only speeding it up. It's only speeding up now since I checked last, because I had taken the aluminum foil off, so the boil in here had decreased, but now it's just catching up. So we have more waiting to do, but we're ready to be ready. Okay, so here we are about 10 hours later. Everything's cooled down. I've got some of the remaining nitric in here. And what I have produced so far is, let's call it 400. So I'm going to dismantle this part of the still, dump what little is in there. I don't think it's even another 450, which I don't know to be disappointed or happy about that result, but I'll get more into that in a second. All right, we're going to get this poured off. If you can see that, it is fuming immediately, so we're up there. I am wearing these gloves here. These should not be flammable, and I'll show you why I'm wearing them this time, whereas I did not last week. There we go. All right, so where are we at here? Get it to settle down. So it looks like we got roughly 450. This isn't complete level on the cardboard, but about 450 of concentrated red fuming nitric acid. And the reason why I'm wearing gloves this time, you see this spot on my hand here? That's just the staining from pouring off the batch from the short video I made not even a week ago. I mean, I've scrubbed with baking soda, Dawn dish detergent, everything I can, but it's just going to be there until it's not anymore. And because of what I do for work and what I do here, and because I have a bunch of dogs, my hands are always stained. Not necessarily dirty, but except for under the fingernails, always from the dogs. So if you point that out in your own mind, that's why. It's just the life I lead. Okay, so what I'm going to do is show you what's left. All right. This should be completely cooled. Just a very crystalline structure in there with my stirring stick on the bottom. And then that's going to be it. In conclusion, I got 450 milliliters of this red fuming nitric acid. I was expecting a bare minimum of 650, and why did I not get that? I don't have the best answers for you. When I shut this down last night around 2 o'clock in the morning, I just had to go to bed, and I couldn't sleep and leave this unattended. So is there more locked up in here? I mean, there could be. There could be. So I am going to answer that question, not on this video, because I'm immediately starting another batch. As a matter of fact, I'm not even going to clean that because that's got nitric acid staining on it. Why not just keep it? I'm going to clean this up completely and all of that apparatus. And I'm just going to let it run till it's not dripping anymore, or it's not dripping anything that to me that says it's nitric acid. So we'll get a max yield out of it, and we'll see what you can get. But I'm quite stumped as to why I didn't get at least 650. But this concludes the video. Thank you for watching, and if you have any questions, shoot me a message. If you'd like to learn more or just join me on this journey, just feel free to subscribe. I'm not an expert on anything at this point. I'm just really getting started on my refining journey. So for those of you with me, thank you. And those that find me, hang around for a bit. All right, take care.